let's go ahead and get started with this problem. Hopefully you've had a moment to look at it. Hopefully you recognized it. You said, wow, that looks very similar to the conversation we had yesterday. But it's not quite the same. Can anybody tell me real quick what is different about this problem? Go.
It's starting on -2 instead of 0.
Yeah, it's starting a little bit further over, isn't it? Yeah, that's subtle. But as scientists, we have to look for the very different subtleties from one thing to another. So that's a piece of advice to you. It is starting at -2. So thank you. We've already answered the first question, haven't we? It's starting at -2. I'm going to go ahead and write that down. Nice job. -2 what? It's not labeled on here, but these are measured in, I think, kilometers, because it says kilometers here. So I think if we read that, I'm thinking that's in kilometers. So I'm going to say that the position is at -2 kilometers. We doing okay? Yeah? All right. My table right back here, the L-shaped table. What did you get for the final position? -5. And you just look to see, so we're just following the arrows. The arrow ends at -5. -5 what? -5 kilometers. Yeah. All right. 2 down, 2 to go. What is the total displacement of the car? My back middle table. What did you guys say? Total displacement of the car. -3 kilometers. Now, I don't see, well, I guess I do see a -3 there, but where, can you tell me where you got that -3 kilometers from? Right. So if that wasn't really super clear, let's just make sure, right? If we're talking about displacement, that's just change in position. So they said, oh, well, it ended at -5. It started at -2. Minus the negative is plus a positive. That's where the -3 comes from. Okay. What was the total distance traveled by the car? My back L here, what did you guys say? Total distance traveled by the car. So I'm looking at you, Alex, Josh. What'd you guys get?
We didn't get it.
You didn't get it? Can I help you? Can we do it together? Yes. Fantastic. So what does distance mean? Can you guys help me out? What does distance mean? How far? How far it's traveling, right? It's like how many steps or how many kilometers is the whole thing. So if you put the odometer, because it's a car, right? Odometer on the car, how many is it counting to? So let's count, shall we? 1, 2, 3, 4. 4 kilometers? Yeah? And then we can count back. 5, 6, 7, 8, 9, 10, 11 kilometers. Now, do you have to count it? No. You can add it, but I want to make sure you see where that's coming from. So I'm not trying to treat you poorly. I'm just trying to show you kind of where things come from. So yeah, that's where the 11 comes from. Now, the distance isn't negative because we're just counting them up. How did these two numbers compare to the answers that you had yesterday? The distance is the same. Tell me about the displacement. Do you remember? Did you have it written down? Do you recall?
It's the same as last.
Same.
But different.
I don't know what reference you're making, but I will tell you, we have a children's book at our house that is called that, and it's all about two kids that are living in very different existences. It's fair. I'm just saying. We have similar experiences, but different as well, right? Yeah. All right. These are the same, even though this is different. Here's the thing that I want to make sure that you understand. Does the initial position dictate displacement or distance traveled? It does not. I could have taken, literally what I did to make this problem was that I put this into paint and then I cut this out and I moved it over. Literally that's what I did, okay? And I could have moved it over to -132. But these things still would have resulted in a displacement of -3 and a distance of 11, okay? In your notes, you may want to add in that little section that said defining motion. Remember, we had all of this stuff written down. You may want to make a little note here that both distance and displacement are not dependent on initial position. Okay, they're not dependent on the initial position. It's only how many steps you take or how far you go for distance, and it's only the change in position for displacement. Okay? Sound good? Okay. We are going to, I'm going to pause something real quick here. Oh. I'm going to hand back. All right, so physicists, we haven't really looked at this list. Yeah, but we did the warm-up problem. We did our measurement quizzes, so good for us. Again, I need to make sure that they're all in my basket. So if you didn't put it back in the basket, make sure you do that because I need them back, okay? We're going to finish problem 11 that we were so rudely interrupted by the bell yesterday. So I want to make sure we get that. We're going to go through that yellow worksheet, and then we're going to start a lab today. We've got a lot to do. It is our first long day of the year, so we got a little bit extra time today. We're going to jump in and get started. So go ahead and pull that homework out. Remember yesterday we were working on this. Got to get our brains back into this mode. So make sure that you've got that homework out. You probably need a calculator, so if you don't have a calculator, make that happen right now as well. There you are. I don't know, where. All right. Our transition time, I kind of messed that up, and I apologize. So let's jump in here. So you may not have been thinking about this problem for the last 24 hours, so let's think about it real quick. Remind ourselves what the problem is about. Runner A starts 6 kilometers west of a flagpole and is running. Runner B starts 5 kilometers east of a flagpole and is running. We want to know when they're going to meet. If they say 1, 2, 3, go. We figured out, we drew a picture because pictures are always helpful when we're trying to get our heads around something. So we drew ourselves a picture. We wrote down some givens, and we got to this point here. We said that together those two people have to run 11 kilometers towards one another, right? We said that that's going to be some distance A and some distance B, and each of those distances is going to be the velocity of that person times some amount of time. But I think that we agreed yesterday that the time had to be equal for A and for B. Is that sounding familiar to you?
Yes.
Okay, awesome. So I think maybe, but I can't remember for sure. Did I ask you all to find that time?
No.
Yeah? Okay, just think about
Yeah,
it.
you said just think about it.
Well, then think about it right now and do it. I'm going to give you 30 seconds right now, if you have not done so yet, to find that time. Do it right now. Make it happen. You've got a calculator. Every person does this right now. Get it out and do it. Don't wait for somebody else. You do it. I want to see calculators not flying, being used. Right? No, I caught myself before I said that, right? Yeah. Go, go, go. So we've got 11 kilometers equals 9 kilometers per hour. Oh, sorry. Bam. There you go. Times t plus 8 kilometers per hour times t. Can you solve that for t? The answer is what?
Yes.
For sure you can. Of course you can. You got 2 things with a t. What are you going to do with these? Combine them. 8 plus 9 is?
7.
That was a disappointing.
Oh, that was really sad. Yeah. I'm going to assume it's because it's Friday, but it's not okay anymore. Thank you. 17 kilometers per hour times t is equal to 11 kilometers. Now what do? Divide. Divide 11 by 17. Who said no? It's okay. I mean, sometimes I do stuff wrong. And so I want you to pay attention and make sure, because I've been known to make a good mistake in my time. I really have. But I think I'm okay on this one. 11 divided by 17 is what? Not 1 point something. You got something bigger on the top. That's a lot of sig figs. Let's do it to like the 100th. What do you got? 0.65? What are the units? Hours, because you've got hours in the denominator of the denominator. Denominator of denominator means it's the numerator. All right. I got 0.65 hours. How are we doing? Question?
Can't you also do both the problems separate and then add them together and divide by 2?
Absolutely can. Yes, and that's totally fine. I was just talking to Mrs. Murphy about this question yesterday, like after school. She's like, this is a hard question. She's like, this is a hard question. And so I did it, and I did it this way, because this is the way that makes the most sense in my head. She did it one way, and it's really adorable because her husband is an engineer and is really excited that she's teaching physics this year. And he like really gets excited when she's like, I gotta do my homework, because he likes to do it too. And apparently he did it a totally different way. So like 3 totally different ways, all that got you the right answer. You with me there? Yeah, so absolutely, lots of ways. As long as it's good physics that's sound, then you're okay. Is that the same answer you got too? Awesome. Fantastic. All right. Are we done? I don't know. What did the question ask? Let's look.
Where they would meet.
It asked where they would meet. Please stop the crosstalk, guys. Shh. It asked where they would meet. Are we done? We have a time. Shh. Please stop. Okay? It's just as distracting to do that as it is when they talk. Got it? I'll manage it. You manage you. Okay? Thank you. 0.65 hours. How do I use that to find where they're going to meet? Ideas? Nate, you look like you had an idea.
It was a prayer.
Oh. Do you wanna like start thinking out loud or not yet? Talk to your tables. Talk to your table mates, not the table itself. What might you do? How are you gonna find a distance from this problem? Because right now you just have a time. Talk about physics, not about other stuff. Figure this out, friends. You do know how fast it's going. I don't know who asked that, but yes, you do. And you know how far or how long it took. All right. Sam, you sounded excited about your.
I'm trying to think it through.
Well, can you articulate it loudly what you were thinking?
Yeah, it's like I was thinking since we know the time, how fast they're going.
Yeah.
We could plug that in to find the distance.
You absolutely can. That's absolutely right. Because we know that delta x equals v times t, doesn't it? For sure. So we need to pick a person, A or B. Who do you want to do? Which one? A. I don't care. If you want to do B, you do. That's all good. I'm gonna use person A because I heard a lot of people yelling A. Okay. The velocity is 9. The time is 0.65 hours. How far did person A go? 9 times 0.65? Plug it in, friends. You got to do it. 9.85, 9? 5, I was going to say, that sounds too much. 5.85. 5.85 what? Kilometers. So is that the right answer?
No.
We're close, though. We are so close. Let's go back and look at our picture. I was studying person A. Person A started out how far from the flagpole? 6 kilometers? And how far did person A run before they met person B? 5.85. So quick question. Did person A make it to the flagpole or no? No, didn't make it there. Made it close, but not quite, right? Close, but not quite. They made it to like here. So I want to know how much further they are from the flagpole. 0.15. Where do you get that from? 6.0 kilometers minus the 5.85 kilometers. Without a calculator, we can do that. Their meeting point is 0.15 kilometers. Thank you. West of what? Yeah. Bam. That's it right there. 0.15 kilometers west of the flagpole. Okay? I want to reiterate because of that reaction right there, right? A problem like this will not exist on your test. Okay? This is a big, chunky, hard one, but you can do it. We just did it, right? Look at us. We're physicists. Yay for us. But if you can do hard problems, we good? If you can do hard problems, can you do easier problems? For sure. Okay? That's why we do this. All right? Questions about this before we move on? All right. Congratulations to you all on working through that really tough problem. All right. What I'd like you to do right now is to get out your position versus time worksheet. That's that yellow half sheet that we handed out yesterday. Pull it out, pull it out. All right. So listen up carefully so that you know what's going to happen. Each group is going to come on up. I am still learning names, and also I recognize that not everybody in this room knows everybody else. You're going to get to know everybody throughout the year, but this is an opportunity to actually put a name and a face together. So team 1 is going to come up in just a moment. Please listen. They're going to share names so that we know who everybody is, okay? And then read the questions and then explain your answer, okay? Everybody will have an opportunity. It will be super fun and great. Also, I probably will ask some follow-up questions because I really, really want for you all to understand this as we go together, all right? Team 1, are you ready to go?
Yeah.
Come on up. All right. I also want to remind you that we are staying positive and we are cheering on everybody, right? That's what we do.
Let's go, dude. Let's go, everybody. I'm sorry.
All right. So again, names first, and then read the question. Tell us your answer. Go ahead and do names first.
I'm Ryan.
I'm Kaylee.
Haley.
Ad.
Thanks. All right. Make it happen.
Okay, so the question was, do the cyclists start at the same point? How do you know? If not, which is ahead? So we said no because B starts higher on the graph for the meter value.
So yeah, go ahead and point it. You can point at the graph so we can understand. Is that making sense to you guys?
Yeah.
Yeah, so it's further up when time equals 0. And because it's further up when time equals 0, it means that it's ahead. Nice job, you guys. Before you go anywhere and before we give them applause, I want to let you know that this is your opportunity to fix your answer on the yellow sheet. So you're engaging with this conversation, and if your answer doesn't kind of match that, then fix it now so that you can use this to study from later on. Okay? Nice job, you guys. I want to give you a hand. Yay! Good show. Team 2 can come on up as we're doing team 1. Again, fix your answers if you need to. This is your opportunity for learning, friends.
Hey.
All right, come on. All right. Names first.
My name is Josh.
I'm Ben.
I'm Jordan.
I'm Nate.
Awesome. The question was?
We had number 2. Jordan, you
7 seconds. Which cyclist is ahead and how do you know?
We said cyclist A is ahead because the line at that point is higher.
So maybe Nate, can you point at what you're talking about here?
Right there.
Cyclist A is ahead because after 5 seconds, cyclist A passed by cyclist B. And where they're going.
And so cyclist A is further along that displacement, right? Further over. Therefore, we would call that ahead because it's in the positive direction. Nice job, you guys. Well done. Give them a hand. Oh wait, you're walking away. But I'm going to ask you a question as you're walking so you can answer it from over there. My question is, at 4 seconds, which cyclist is ahead and how do you know?
Cyclist B.
Cyclist B. Why is cyclist B ahead at 4 seconds? How do you know that?
They're higher than me.
Higher slope. Not slope, higher.
Higher what?
Line.
Higher line.
On the meter.
Higher position, right? And part of the reason that I asked that, thank you for saying that, friends. Listen up. I want to make sure that you get this. On questions 1 and 2, does the slope matter at all? It does not. The slope does not matter at all on questions 1 and 2. It's only about the location. If you put a dot on one of those lines at any given time, that's what we're looking for. Write that down on your yellow sheet if you need to. If you haven't done that, make sure you do. Group 3, come on up. Cheer them on as they're coming up. Sure, why not, right? Come on up. All right. Introduce yourselves, read us your question, tell us your answer.
I'm Grace.
I'm Erica.
I'm
Haley.
I'm Alex.
Awesome. Go for it.
Question 3 says, which cyclist is traveling faster at 3 seconds? How do you know?
Okay. And your answer was?
Okay, it is. Okay, so line A, because it's above line B, according to the x-axis, so it's traveling a farther distance at the same amount of time.
Okay, so I just want to make sure that we're understanding, so where is 3 seconds? Can you point on the graph to where we think 3 seconds might be? Ish, right? So at 3 seconds, so we're talking about like somewhere over here. You guys with me? You can see that?
Yes.
Okay. So who's ahead at 3 seconds?
B.
B, right? Because B is further up. But does that mean that B is moving faster?
Absolutely.
No. And I can't remember exactly what you said because I don't have that thing to reference, which is okay. But you said, did you say B was going faster? Or no, you said?
Line A is going faster.
So cyclist A is going faster. And what was it about the line that made it so that you knew that they were going faster?
At like the same it's like the same amount of time, but like they're traveling at different like distances.
Okay.
Like, not distances, but like faster. So like line A is traveling faster and line B is traveling slower at the same time.
Okay, so I'm gonna open this up to everybody because I feel like there's a word that you want that's defined right now. What word is it that she's looking for? What is different? The slope. Yes. Whenever you're talking about the speed of an object on a displacement versus time graph, the thing that you're looking for, and that's I think what you were saying, you didn't say the word, yeah, is the slope. The slope of line A is bigger than the slope of line B. So even though B is ahead, A is still going faster. My follow-up question for you is, which cyclist is traveling faster at 8 seconds? Take a look at that. You guys all look at that too and think about it. Which one is traveling faster at 8 seconds? A. Why? What's the word?
Slope.
The slope, right? Does A change speeds at all during the story? No. Does B change speeds? No. So who's traveling faster during the whole story? A is always traveling faster. You guys did a great job. Thank you so much. Yay! I need your score on it. All right, question 4. Tell us your names. right.
I'm Caitlin.
I'm Alex.
I'm Brianna.
Thank you, guys. Make it happen.
Question 4 says, what is happening at the intersections of line A and B? How do you know?
We said the cyclists meet and they intersect, so they're at the same amount of meters.
That's awesome. They're at the same position at the same time. Bam, there they are. Hopefully they're on like, parallel tracks or something so they don't like actually literally crash because otherwise it'd be a sad story. But yeah, that's awesome. Nice job, you guys. Yay!
Working.
All right.
Good job.
Keep on.
That's great.
All right, keep cruising. Let's go. Let's go. All right, attention is way up here, right up at the front. Names first, please.
I'm Maddie.
I'm Sierra.
I'm Annie.
I'm Drake.
All right, so our question is, describe how the motion of cyclist B as shown in figure 2 differs from cyclist B in figure 1.
Okay, so it'll kind of flip back and forth to look at this one. What did you guys say?
Okay, we said in figure 1 they're going one direction, and then in figure 2 they're going the opposite direction.
How
Possibly.
do you know? It doesn't say how do you know, and I don't know why. So I'm going to ask, how do you know? Not to put you on the spot, I'm just curious.
Like in meters, you can't go like a negative, but you can go backwards. So it's like going down.
Yeah. So I'm gonna flip back over to the other one real quick. So if we look at cyclist B, that's this one here, right? It's going up. So if you look at one time to another time, their progress goes in the positive X direction. Is that fair?
Yeah.
And so I think what I'm understanding you're saying is that in figure 2, they start here and then they go this way over time. So they're further away and then they're getting closer to the origin. So that would be going, you said opposite direction. Yeah, awesome. Nice job, you guys. Well done. All right, group 6, come on up.
All right, spirit.
All right, we need to do names first, please. Hold on. Everybody else needs to be quiet.
I'm
Go for
Weston. I'm Dawson.
I'm AJ.
I'm Haley.
And the question was, which cyclist has the greater speed? How do you know? We said A has greater speed because it has a steeper slope.
What do you guys think? Yeah. Can I ask you a question?
Go right ahead.
I mean, yes, I can ask you a question. I'm going to ask you a question now. Would it be possible for cyclist B to be going backwards and also have a greater speed than cyclist A?
Yes.
AJ, there's a pink marker right there. Can you grab it and draw a graph, like change B so that it's going faster than A? What do you guys think?
Yeah.
Does that make sense? So even though it's going backwards, it's still going faster than A. Yeah?
Yes.
Fantastic. So it's not just about which way it's going, but it's about the steepness. I love it. Nice job. Can you erase that just so I don't get super confused? And let's give him a hand. Yay! All right. Team 7. I keep meaning to remind you, and I keep forgetting. If you have not been updating these or answering these or whatever you need to do, you are welcome to do that, okay? I'll give you a couple seconds at the end too, but I just want to remind you that this is you being engaged, not just turning your brains off while somebody else is talking. We have Team 7. Can you tell us your names, please?
Cole, Brian, Sam,
Olivia.
Thank you, guys.
and the bikers meet each other.
Read the question out loud.
Describe what is happening at the intersection of lines A and B, and they cross paths. So what's up?
How's it going?
That point
Keep
right
going?
there.
Yeah.
How is that one different than the other one? So the other one, I don't remember which group, I guess it was group 4.
They were going the same way, just one does the other one.
Yeah. So in question 4, it was like, you've got one car going on the interstate and another car going on the interstate, and they're going to pass, right? But in question 5, that's more like you're driving on Dubuque Street, right? You've got one car going this way and one car going this way. So in both cases, they're going to meet each other. Again, hopefully not colliding. That's a few units from now. Okay, but they're going to be at the same X position at the same time. Nicely done.
Thank you.
Go run.
Woo.
Go win.
You're saying the best for us, perhaps? All right, group 8, come on up.
Basically the same as 6.
All right, full attention right up here.
I'm Kaylee.
I'm Tessa.
I'm Luke.
So our question was, which cyclists travel at a greater distance during the first 5 seconds?
And we said A because it has a greater slope.
What do you guys think? Yeah.
Great.
Would it have mattered how many seconds it said? 12 seconds, 2 seconds? Doesn't matter. Same, right? So as long as you have a bigger slope, you're going to travel a greater distance in the same amount of time. Nice job, you guys. Well done. Hold on, before you go anywhere. Stop. I need you to listen very, very carefully. Take a minute right now before you turn your brains off, because the bell's not going to ring quite yet. Make sure you have good answers to all 8 questions. Make sure you have good answers to all 8 questions before you move. Erase your boards and then move back to your spots.